This is chapter 6, problem number 20. The lucky number for this problem is 0. A baseball traveling at 32 meters per second moves a fielder's gloves backward by 25 cm when the ball is caught. What was the average force exerted by the ball on the glove? Okay. So a ball is moving. So let's say the ball is moving over here, and this person, he tried to catch the ball. When he caught the ball and his hand actually moved back a little bit. How much little bit? Move back by 25 cm. So I'm going to put everything into standard unit. So move back by 0.25 meter. Okay. So earlier this semester, what we know is when you have initial velocity, you move to final velocity and it stopped. So I'm going to write down that magical formula 5 weeks ago. That is V final square minus V initial square. That is equal to 2 times acceleration times D. In this case, D is 0.25 meter. Initial velocity, we don't know yet. Well, actually we know it's given, okay? And the final velocity, it will be, when it stops, it will be 0. So 0 minus initial velocity, 32 meters per square, that it will be equal to 2 times A times D. D is 0.25 meter. If you look at this, then you realize that A is a negative number. Of course, because it will decelerate from 32 meters per second to 0. When it decelerates, A can be a negative number. Okay, so let's see what this A is for now. So A is equal to negative 32 square divided by 2 and then divided by 0.25. So what I get is 2048 meters per second square. All right, so that would be the acceleration. Okay, so when the ball is moving, okay, so what is the kinetic energy? So this would be the new magical formula. Kinetic energy is equal to half times m times v squared, which is equal to half times m, the mass. Can I use 145 over here? No. Why? Because I have to have the standard unit. In this case, it will be 0.145 kg. We have to convert it to kilogram. So it will be 0.145 kg multiplied by, it's the right unit, so 32 square. So what I get over here, kinetic energy is equal to 0.5 times 0.145 times 32 square. Make sure you put the square in because 20 plus years ago when I was taking physics, usually I forgot to put the square. Okay, so over here in terms of joules, I have 74.2 joules. So that's the kinetic energy. Okay. All right, so what are we looking for? Okay, so we are looking for the average force. Okay, so this is the energy, the average force in order to stop from here to here with this distance. Okay, so work is equal to force, because the force is kind of a constant here. Okay, force times distance. Okay, so for work is energy is equal to kinetic energy, so that would be equal to 74.2. Okay, so in this case, if you want to get the force, you can have 74.24 and divided by the distance, so you divide it by 0.25. Okay, so the force over here is 297 Newton. That would be the force. Okay, but this is a good review. At least you know what's going on. The lucky number for this problem is 0.